We're good to go now.
All right. Yes, I'm using the theme apparently. All right. All right. So again, take two. I'm Bradley. Uh, so first, a little bit about me. I enjoy long walks on the beach, and that was part of my farmersonly.com application. So I'm a first year CSEC student. I've had about 5 years of web development experience, so I mostly, am familiar with like web development language, but I've always loved CTFs. They've always been fascinating to me. They're just kind of like combining two things. I love technology and puzzles, so I'm really interested in them, and that's really what got me into cybersecurity in the first place. Um, so I am going to be talking about um, beacons and C2s. So this is something that John actually turned me on to. And so I'm in the Rubber Ducky mentoring group. And yeah. And so we've been learning about deploying code to hosts via a bad USB. And so, one thing you can do with that is you can drop a beacon onto a host. Well, there's an issue with that, and that's that most of the payloads out there that can be auto-generated by tools will just automatically get caught by antivirus, Windows Defender, etc. So I was focusing on primarily attacking a Windows target, and the C2 can be run on pretty much anything with Python in it. So first we're going to go over some concepts if you're unfamiliar with what beacons or C2s are. Then we're going to go into the beacon, the C2, and finally a demo. And so honestly, when I went into this, I didn't really know what any of this was. I was vaguely familiar. And so apparently a beacon is just a piece of software that sits on a target host, and it will call back to the C2, every now and then, just to tell it that it's alive and listen for some instructions. Now the C2, that software runs on a remote server. Apparently stands for command and controls. I did not know that until I was making this presentation, actually. So this, the C2 will actually provide instructions to the beacon on what to do. So first, we're going to go to the beacon. He's our secret little inside man, as I like to call him. So first, I just broke down what does the beacon need to do. I decided that I was going to write this in C++. I'm familiar with C++. If you've done like Arduino programming, that kind of thing, very similar. But of course, then you get into the Windows APIs, and that's just absolute chaos. And you have no idea what's going on anymore after you've gone through like 500 iterations of seemingly the same thing. You don't think you changed anything, but somehow it magically works this time. So first, our beacon, it just needs to be able to sleep. Like, if anything, it just needs to be quiet on the target host and not alert anybody of anything until we really want it to. Then it needs to actually ping back to the C2, say, hey, I'm alive. And finally, it needs to be able to execute commands that the C2 sends it. So this is kind of like the three-step process that I followed to kind of be able to build out the C2. I use Visual Studio 2019 to develop this. Makes it really easy to debug, that kind of stuff. And I'm pretty sure this is available through RIT's like Azure software portal thingy. Yeah. So sleeping in C++, wow, turns out just really easy. I don't know if this is the best way, but this is the way I did it because it's one line of code. My demo just kind of sleeps for every 10 seconds. Obviously, you just put in how many milliseconds you want it to sleep for, and it just halts all program execution until then, and it just makes your program hang right at that line of code for a certain amount of time. And so next, obviously, we need to ping the C2. This is where stuff gets really complicated, and I think that this is covering like one of the comments, but that's okay. So basically the main chunk of code up here, I just realized I can point with my mouse. So basically the main chunk of code up here, it's just really just setting up what type of socket our beacon is going to connect back to our C2 on. And so I just went with a TCP socket, and there's just a bunch of other stuff that I found in the Windows socket tutorials through the Windows APIs. And next, this little bit of code, it just takes our IP address and our port and then resolves it into an object that's parsable by the Windows APIs, which is the result object. And so then we pass that to the socket function, and that just gives us out a nice little socket that we can reuse. And so if we want to connect to the socket, we just run connect, pass it the socket we want, and of course, this is all in C basically. So you're going to need to do a lot of passing objects through parameters and pointers and stuff like that. So it does look kind of complicated if you don't know C or C++. But then we can send data over the socket once we've set it up. We store this iResult gives us an error code if something goes wrong, or so we know if our socket actually wasn't successfully created. And you can see that down here with the socket error. Next, how do we execute commands? So this I kind of had to break down into multiple steps, because it was really easy to just kind of spawn a command and just let it spiral out into nowhere and finish, and maybe leave a process running on the host forever until it gets closed somehow. But really what we wanted to do is get output back from the beacon and the child process. Because obviously the beacon, it's just listening to the C2 and then executing commands. It doesn't know how to interact or run a command directly, just like command prompt would, for example. So we just need to spawn a command prompt instance. But first of all, we need to be able to send data to and from that child process. So we use these things called handles and pipes. And so we create a bunch of pipes and set some security information about them. It's not really important. Like I said, this is all in the Windows Sockets API documentation. Next, we got to actually start up the child process and let it know where to send output, get input from, etc. And so here, this is how we do that. We just this process information object is really important because this is actually how we're going to be able to kill the child process to make sure that we don't have runaway processes that are left running on the target host, because that's one thing that can be detected. If all of a sudden I just see 25 different command prompts open just sitting there doing nothing, that's you immediately know something's wrong, and people can see what processes are spawning those command prompt processes. So we just we pass it some pipes, where to send our input and output. And here, this line of code here, the create no window, this makes the process hidden. But currently, I am experiencing some bugs with the hidden process where the pipes kind of break, and not exactly sure why yet, but that's what development is for. So this will just return true or false if the process was successfully created or not. And lastly, once we're done running it, we need to make sure we kill it so that way it's not detectable on the host, because most of these commands run in less than a second or maybe even a few seconds. So if it's just up for a few seconds, and even if a user is interacting with the system, especially if you have that create no window, the user will never know visually that anything was happening. So this is how we kill our process. This is very important so we don't have those runaway processes. We make sure that we close our pipes so that way we don't have like memory leaks, because that's a thing in C. You got to manage your memory. Very important, something I'm still learning. And after we close all this, all of the output that was from the child process is still in these child out read pipes. And so we can still read that output from the child because it's stored in essentially a buffer in memory. And so we just do that, you can set an arbitrary buffer size and read until there's no more output. And then here for debug purposes, I use this to write out when it's in console mode so you can actually view the beacon and it's not hidden. So this is so we can just spit whatever we're getting out from the child process out to the parent process as well. All right, that ends like the complicated, really dense code section, which is really nice because here comes the really easily readable Python stuff. So the C2, I was really beaten down with making the beacon itself, and C2 I was like, I need something easy. And even though I'm not very good at Python, it's a lot easier to write than C++, in my opinion. Some people may disagree. So the C2, I wrote it in Python, like I said, and so again, this can be broken into a few steps. All it needs to do is just listen for the beacon to call back to it. It needs to be able to send commands to the beacon when we want to run something. And then it needs to be able to receive the output of the commands that we told it to run. So it's just a few simple steps. That slide is actually incorrect. I use VS Code to just develop this quickly. And yeah, we're ignoring that. All right. So, we first we got to listen for the beacon. I actually didn't put this in here, but you got to import the socket library in Python. And turns out there is differences between operating systems, which you'll see in a few slides. So check the documentation of whatever operating system you're targeting if you're trying to do this yourself. So first, we just create the socket. It's AF inet, that just tells it what kind of IP address it's supposed to expect. The sock stream, that just sets it to a TCP stream socket so that it will match what our beacon is sending out. Here, we just bind to a specific port on localhost, which is just what the blank string means. And then we start listening for connections trying to come to us. So this line, C and address, C just stands for connection, and socket.accept will actually just kind of hang your code, specifically in Windows. It will hang your code and you actually won't be able to control C out of it, which I've determined. I developed this on Mac, so I was able to control C no problem. It wasn't until I was trying to make this work for this demo that I realized that was a thing. So you kind of need to like spawn it in a separate thread, and that's where Python gets complicated. So then we need to be able to send commands to our beacon. So this is really easy. We just need to have a string, whatever command we want it to execute, specifically in command prompt. And then I just encode it using UTF-8 because that's what it expects, and that just encodes our string into binary data to be sent over the socket. And then, so here's where like the weird OS stuff comes in, because I didn't realize that apparently there's differences in the libraries. So the Windows send function does not expect the length, how many bytes the binary is. However, the Mac OS operating system does require that. I haven't tested it on Linux yet, but this platform.system is a really good way to check. Just it will output Windows Darwin or POSIX, I believe. Yeah. Okay. I got the head nod. All right. Yeah.
You got it right here.
So all right. So then let's see. So now we need to receive output back from it. So this was something that it was kind of a tough challenge for me because you don't know how long the output you're going to receive is, and everything in like C is very like you got to have a buffer of a limited size. So eventually you're going to have to split up the data unless you just make some like completely like insanely large buffer, and you could just never run out of memory. But obviously that's not a good way to write code. So you just blow up the memory and just just give it a lot of room to breathe, right? Yeah. So I tried to write it, as efficiently as possible. And so one thing I figured out is that because we may need to split up the data and send it in multiple chunks, something that we can do is we can send in chunks of however large we want on the beacon side, but on the C2 side, we can just receive it 1 byte at a time. It may not be efficient, but what this allows me to do is define a custom like end of output character that I'll append after the beacon knows it's done reading from the pipe. It will send this hexadecimal FF command. So this is something that's used in UTF-8 by some extended Latin character, which I'm making the assumption that no command is going to output. However, that could be completely false. So this is just my arbitrary data that specifies. So it just kind of loops, receives all the bytes until it reaches the end of output, and then it just breaks. And we'll print the output. And of course, we got to remember to close the connection, or else that creates a bunch of errors on its own, turns out. So here's where I do my demo. Hopefully it doesn't break, all right? Oh, wait. All right.
Already broken.
Yeah. Yeah. I put that there to remind me. All right. So here is, all right. So first, ideally this would be on a separate host, but I'm writing it to make it easy. As you can see here, we can input the IP address of whatever wherever the C2 is we're trying to run back to, whatever port we want to, and then some other parameters. So we can start up the C2, and so it bound to the port, and it's now just sitting there listening for a beacon. So it'll wait here forever until my laptop's battery dies. Then I can guarantee you it won't listen anymore. However, so if we start up this beacon, like I said, my beacon is just set to wait 10 seconds. So there will pop up on the right side of the screen this fancy little time graph that we can see. It just so happens to be labeled at 10 seconds, which is great. So I will move that. So, once it hits 10 seconds here, we should see, there we go. All right, awesome. So now we can send commands. Obviously, this just kind of waits until you send it a command. So here, this window would not be visible, but like I said, there's weird stuff with the pipes that's happening. So if I send the who am I command, I can immediately get output from the beacon. So it ran the command and sent back the output. And of course, it sits there and waits for it to call back because this is lying dormant. You could have where it'll, you could have your C2 just have a queue of commands to run so that this is a little more automated. You don't have to sit here with it. This is just an easy way to test. I can even run dir, and there you go. Now you can see all my folders that are in the current, or all my files that are in the current folder. And then it has a special command, quit, that will kill the beacon in the background. As you can see, Visual Studio did a thing where it stopped debugging because the program ended. So yeah, let's see, go back to presentation. And some possible future work that I want to implement into this. Maybe interactive remote shell. I think that would be a really cool challenge to do. I'm really into just picking some super high goal, trying to reach it, and then maybe settling for something halfway there. But it's cool along the way. Maybe some automated scripts. So just have like a bunch of pre-built commands that will be set to run just back to back to back. That can get you specific exploits or something like that. Also, rubber ducky deployment. Like I said, I'm in the rubber ducky mentoring group, and so possibly I want to be able to drop this beacon via rubber ducky bad USB, and so we can have C2 running on some remote server, just waiting, and we just plug the USB in. Boom, we have a beacon running, and it'll call back in 2 days, and no one will ever know, and possibly more. Thank you guys for letting me present. That is all I have for you today. You have a question? Yeah.
So being a freshman and not knowing a lot, how did you handle this? What did you do to get started?
So to get started, first of all, I reached out to John, and I was interested in doing something like this. I was like, I think I was at the Rubber Ducky mentoring group, and I was just like, I want to be able to get around Windows Defender. I think I might be doing a group presentation with the Rubber Ducky mentoring group in the future. I'll explain some of my work with that, but this was kind of a side project that I wanted to do on my own, just kind of working on being able to get this. This is kind of like one of the foundational things, especially like red teaming and that kind of thing. So yeah, I was just really interested in learning a new concept, so I just reached out to John. He sent me a few resources, and basically Google. Google is your friend. You can learn anything on the internet. This is 2020. There's so much information out there. I taught myself pretty much everything I know about programming, and that's cool because then when you actually have to take a class on it, you can sit there and do nothing. Hypothetically, not endorsing that. All right, is that all? All right, and now it's time for Enzo's talk, all right? All right.